Now let us start with the laws of exponents. Put heading everybody. Laws of exponents. The first law is under multiplication. The law says that suppose you are having a rational number 5, okay? First I am giving you an example. With the help of example, then we will generalize it. 5 is a rational number raised to the power 2. Multiply by again the same rational number 5 raised to the power 4. So law says when there are two rational numbers with the same base, okay, and it is in the multiplication, that time we add the powers. So 5 will be written base one time and 2 and 4 both the powers will be added. So it becomes 5 raised to the power 6. This is the first law. So let us generalize it. If A is a rational number, you are having a rational number A, okay, and M and N are two natural numbers. Then A raised to the power M, rational number raised to the power integer, multiply by same rational number raised to the power another integer, natural number, another natural number. In that case, base is same. In multiplication, we add the powers. Remember this. In multiplication, when both the bases are same, we add the powers. M plus N. Okay, this is the first law. Let us practice a question for the same. You are having 2 raised to the power 3 multiply by 2 raised to the power 10. Same base, in multiplication powers will be added. So it becomes 2 raised to the power 3 plus 10 gives us 2 raised to the power 13. Okay, understood? Please note down this all, both the examples also and the law. Once you write, then tell me, then I will go to the next law. Written, students? Our next law is second one. It is the law of division. Law of division is our next law. Now same ways. A rational number A. Now a rational number A with the power M divided by rational number A only with another power N. A is a rational number and two separate powers M and N are the natural numbers. In division, we subtract. So A rational number with the powers will be subtracted M minus N. And when you have to subtract, so that means first number should be bigger. So the first power M should be greater. M should be greater than N. Then only you can subtract. Let us take an example. Suppose you are having 3 raised to the power 5 divided by 3 raised to the power 2. Rational number 3. Same rational number in division with different powers. So in division we subtract. 3 raised to the power 5 minus 2 gives us 3 raised to the power 3. This is the answer. In multiplication we add, in division we subtract. Note it down. This is the law for division, and m should be greater than n because when we subtract, first number should be greater. Once you write, message me. Okay. Yes. Adipsa, Manya, Huma, done. Kshitij, message me. Done, beta. So going to the third law. Let us revise. In multiplication, we add the powers. In division, we subtract the power. Okay. Now the third law is power of a power. Power of a power. Here you are having one rational number A. One rational number A. A raised to the power m. Rational number A, m is the natural number. इसी का एक और power है. Okay. Power of a power. Already there was one power m and one more power now n. When one base, one rational number is having two powers, one upon another, एक के साथ दूसरा भी. So in that case we multiply the parts. It becomes a m multiplied by n. Take an example. Suppose you are having 3 raised to the power 5. Okay. And one more power is there, 4. So one base with two powers. In this case we multiply. 5 multiplied by 4 gives us 3 raised to the power 20. So these are the 3 rules, first laws. Is it clear? I am putting it in the box. Quickly write down. In multiplication, we add the powers. In division, we subtract the power. When on one rational number there are two powers together, that time we multiply the powers. So I am rubbing the first law. I hope everybody has written the first law. Now the fourth law, we are going towards the fourth law. Okay, the fourth law is zero as an exponent. Write down. 0 as an exponent. You are having a rational number a और उसका power है 0. A raised to the power 0. A rational number with the power 0 is equals to 1. This is the law. You are having 5 raised to the power 0. That means it is equals to 1. 11 raised to the power 0. That means it is equals to 1. Now you are having suppose minus 3 raised to the power 0. That means it is equals to 1. Another you can take minus 2 upon 3 raised to the power 0. That means it is equals to 1. A rational number with the power 0, with the exponent 0 raised to the power 0 is equal to 1. This is our fourth law. Rubbing the second one. Children, ensure that you are writing along with me. Just don't sit. If you will write, you will understand better. Now, the fifth law states power of a product. This is your fifth law. Put the heading. Put the heading. Whosoever joined, please message. Power of a product is the fifth law. You are having two rational numbers. A is one rational number, B is another rational number. Two rational number raised to the power n. A and B are two rational numbers. Two different rational numbers. So when two rational numbers are in product with the same power, in that case, this power is applicable to both A also and B also. That means we can write it as A raised to the power n multiplied by B raised to the power n. This is the power of a product. If two rational numbers are there with the same power in multiplication, A multiply B, AB together written, it is understood that there is multiplication sign in between. A multiply B raised to the power n, that means this power is applicable to A and B both. Let us take an example. You are having 2 raised to the power 2 multiplied by 3 raised to the power 5. 2 multiplied by 3 raised to the power 5. So that means it is 2 raised to the power 5 multiply 3 raised to the power 5. Either way it will go. If it is given right side is equal to left. If it is given left side is equal to right side. Either way you can use it. If it is already given in expanded form, you can make it together in the bracket. If it is given in bracket, you can open it outside the bracket. Understood? What is power of a product? Power is distributed over the product to both the rational numbers. It is applicable on both. Huma has answered. Adipsa has also answered. Now let us go to the sixth law. Our sixth law is dividing powers with same exponent. There are 6 laws in your course, okay? Sixth is dividing powers with same exponent. It is almost similar like the fifth one. It was in multiplication, now it is in division. You are having two rational number. A is one rational number, B is another rational number in division. A upon B. Both are having power m. A upon B raised to the power m. Together they are having a power. So it can be written separately also. A raised to the power m, B raised to the power m. That means this power m is equally distributed on A and B. This is your dividing powers with the same exponent rule. But yes, take care that it is a rational number, so B should not be 0. Let us take an example. Suppose you are having minus 2 upon 5 raised to the power 3. It means this power 3 is on minus 2 and 5 separately also. It can be written this way. So this is your sixth rule. In rational number, ensure that b should not be 0, denominator should not be 0, because denominator is 0, then it is not a rational number. When denominator is 0, it is not defined. Done this much? Abhipsa, Homa, Manya. So these are the 6 laws. Now we are going to practice these laws on the questions. I am rubbing the board as you all have written. Kshitij also. While solving the given questions, every time you can turn the page and check your laws, okay, so that you get it clear. Of course, I will be explaining, but yes, every time you revise it. The question number 1 is, put heading, simplify and express in exponential form. Simplify and express it in exponential form. This is the question. First part, let us start from the simpler, then we will be going to the complex, okay? 7 raised to the power 4 multiplies 7 raised to the power 5. First law of multiplication. Two rational numbers with the same base, different powers. In multiplication, what do? Everybody answer me. Same base and two different powers. 7 raised to the power 4, 7 raised to the power 5. In multiplication, what do? We add. Yes, correct. 7 raised to the power 4 plus 5 gives us 7 raised to the power 9. In multiplication, we add the powers. Absolutely correct. All are giving the answer, right? Zoya has joined the class. Hello, Zoya. We are doing the laws of exponents. We have just finished all the 6 laws and now we are starting with the practice sums, okay? So laws part, you can just see the recording when I will be uploading it. Join us with this practice sums. B part. The question is minus 5 raised to the power 2 and again one more raised to the power 3. One base with two powers. Which law? One base with two powers. Power of a power, third law. In that case, what do we do with the powers? Waiting for your answer. You can turn the page. Yes, law 3. One base and two powers. We multiply the powers. Correct. Minus 5. 2 multiplied by 3 power in it. And then it becomes minus 5 raised to the power 6. Correct. We multiply. Everybody has answered correctly. C part. 2 raised to the power 5 multiply 5 raised to the power 5 multiply 6 raised to the power 0 is another question. Here two laws will be implemented together. See, first is 6 raised to the power 0. Which law? Fourth law. 0 as an exponent. A rational number with power 0 is equals to? First tell me this. A rational number with power 0 equals to? Fourth law. 0 as an exponent. Yes, Avipsa correct, Manya correct. It is equals to 1. So 6 raised to the power 0 is equals to 1. Now, these two different rational number, this is A, this is B with the same power. In multiplication, we add the powers. This is the first law. Revise it. In multiplication we add the power. So it becomes no, this is not the first law actually. This is your fifth law. Powers are same. Powers are same and base are different. So 2 multiplied by 5 raised to the power 5. It is in expanded form. We have put it together in the bracket. Multiply by 1. 6 raised to the power 0 is equals to 1. So it becomes 10 raised to the power 5 multiplied by 1 gives us 10 raised to the power 5. This is your fifth law. Two different base, same power. Power of a product. Correct, Avipsa. Zoya, correct. Next question. Check out one more. The question is given to you. 2 raised to the power 20 divided by 2 raised to the power 15. Division. It is in bracket. Multiply by 2 raised to the power 3. So let us solve it. This bracket first. It is in division. In division, what do? We subtract the powers. So 2 raised to the power 20 minus 15 is the first bracket. Multiply by 2 raised to the power 3. Go further, it becomes 2 raised to the power 5 multiply 2 raised to the power 3. Now same base, different powers. This is your first law. In multiplication we add the powers. So becomes 2 raised to the power 8. Yes. Kshitij correct, Zoya correct, Avipsa also correct. Sorry. Next, E part. Let us take now rational number in the P upon Q form. Minus 6 upon 7 raised to the power 3 multiply by 1 upon 3 raised to the power 3. Yes, Huma, correct. Now how we will solve this question? When you are having it is in P upon Q form, so always remember cuttings will serve our purpose. We will open it, do cuttings and write in simplest form. Let us start. Minus 6 upon 7 raised to the power 3 means we have to write it 3 times. Kshitij has tried to solve. Let us see, Kshitij. Minus 6 upon 7 multiply minus 6 upon 7 multiply minus 6 upon 7 3 times. Next is 1 upon 3 3 times. 1 upon 3 multiply 1 upon 3 multiply 1 upon 3. Now let us do cuttings. 3 ones are 3, 3 twos are 6. 3 ones are 3, 3 twos are 6. 3 ones are 3, 3 twos are 6. Now numerator is having 2 and denominator is having 7. No more further cuttings possible. So let us write the final answer. 2 twos are 4. 4 twos are 8. No, we have to write in exponential form actually. Not the final answer. Exponential form. Minus 2 upon 7 is coming how many times? 1 time, 2 times, 3 times. Minus 2 upon 7 raised to the power 3 is the answer. Who has given? Kshitij correct. Zoya correct. Manya correct. Beta, just put the minus sign also. Minus 2 upon 7 raised to the power 3 is the exponential form because question was asking us to write in exponential form. It is not the simplify that we have to find the final answer, only exponential form and leave it. Now one question I am giving to you all, you will be trying and tell me the answer. The question is, this is done. This is also done. Okay. The question is F part. You have to try 6 raised to the power 3 and further it is raised to the power 2. Everybody note down. You have to try it. Multiply 6 raised to the power 4. This is all together in one bracket. Divided by 6 raised to the power 5 is the question. Kshitij, solve it. Method is important. Everybody, this is one base with two powers, so that means when two powers are there together with one base, we multiply, it becomes 6 raised to the power 3 to the 6. Multiply by 6 raised to the power 4, continuing in one bracket, divided by 6 raised to the power 5. So solve it. 6 raised to the power 6 multiply by 6 raised to the power 4. Continue in one bracket, divided by 6 raised to the power 5. Same base with different power. In multiplication we add the power, so it becomes 6 raised to the power 10 divided by 6 raised to the power 5. Now we left with division only. So let us in divide, what do? We subtract the powers. 6 raised to the power 10 minus 5 gives us 6 raised to the power 5 final answer. Correct. Zoya, Abipsa, Sanchi, Huma, correct. So in these questions we have applied all the 6 laws of exponents. Let us revise. In multiplication, same base, we add the powers. Second rule. In division, with same base, we subtract the powers. A rational number with 0 as an exponent equals to 1. One rational number with 2 powers, like this is the case. One rational number with 2 powers. Here we multiply. And when a rational number is given in bracket, it can be expanded separately. Power is applicable on both, in multiplication also and in division also. Now let us go to the next question. Shall I rub the board? If you have done, everybody has done. Rubbing the board. Next question is simplify. Put heading. Question number 2. Simplify using laws of exponent. Only simplify. And you have to use the laws of exponent. A part. First question. The question is given 2 upon 3 raised to the power 3 multiply by 4 upon 9. Observe the given question. First number is rational number 2 upon 3. Second is 4 upon 9. Now to apply the first law, it is in multiplication, so yes, we can observe the first law can be applicable, but for the first law, base should be same. So let us make the base same. How we can make 2 upon 3 raised to the power 3? How we can write 4? 2 raised to the power 2. And how we can write 9? 3 raised to the power 2. So yes, 4 upon 9 can be written as 2 upon 3 raised to the power 2. 2 2s are 4, 3 3s are 9. We have simplified 4 upon 9 in the terms of 2 upon 3. Now both the bases are same. In multiplication, we add the powers. 2 upon 3 raised to the power 3 plus 2 gives us 2 upon 3 raised to the power 5. Yes, correct. क्षितिज correct. मान्या 6 raised to the power 5 नहीं है बेटा, ये कौन सा क्वेश्चन लिखा है? Okay, क्षितिज correct. Okay, Manya has written the previous answer perhaps. 6 raised to the power 5. How 6 raised to the power 5? Okay, this is the previous answer. Okay. 2 upon 3 raised to the power 5. Correct. B part. Next question. Minus 1 upon 3 raised to the power 3 multiply by 3 raised to the power 2 multiply by 2 upon 5 raised to the power 2. Yeah, correct. Manya correct. Zoya correct. Kshitij correct. Now in this question, let us observe the rational numbers first. This is minus 1 upon 3. This is only 3. This is 2 upon 5. None of the rational number can be turned into each other's form. Okay, so that means we have to do another method. That yes, minus 1 upon 3 is 3 times. 3 is written 2 times. 2 upon 5 is also written 2 times. Each question may have a different method. You have to observe and find out which method will be applicable to it. Let us start. Here cuttings will work. Minus 1 upon 3 multiply minus 1 upon 3 multiply minus 1 upon 3. We have expanded the first one. Now multiply by 3 square. That means 3 to be written 2 times. Now 2 upon 5 raised to the power 2, it is to be written 2 times. Okay. Now what we will do? We will do the cuttings. Here no denominator, so you can put the 1. 3 ones are 3, 3 ones are 3, 3 ones are 3, 3 ones are 3. Any further cutting, numerator is having 2, 2 and denominator is having 3, 5, 5. Now no more further cutting is possible. So just simply we will multiply. 2 2s are 4 and denominator 5 5s are 25. 25 multiplied by 3 is 75. And which sign in the numerator? There is minus sign 3 times. Negative rational number with odd power is negative. Minus minus plus. Plus minus minus. So minus 4 upon 75. Correct, Kshitij? Huma correct? Try the next question. C part I am writing. (25) multiply by 10 raised to the power 5 multiply by 3 raised to the power 5 upon 6 raised to the power 10. No, 6 raised to the power also 5 multiply by 5 raised to the power 7. This is your question. Here we have to simplify it. So let us observe the numbers first. 25, yes, it can be expanded as 5 times 5. 10, yes, 10 can be written as 2 times 5. 3 is a prime number, 5 is a prime number, 6 can also be written as 2 times 3. All the composite number we can expand. Why? It will help us. If we will write 2 times 5, then 5 and 5 two common base we will be having. If 25 we will be writing as 5 times 5, then it will also give us the common base 5 which is in denominator. And 6 if we will write as 2 times 3, then yes, that 3 can cut with the numerator 3. Numerator and denominator we have to do the cuttings. So for that we are going to expand it. 25 can be written as 5 square. 5 times 5, 25. Multiply by 10 can be written as 2 times 5. Common together in one bracket raised to the power 5. Expanded 10. 10 can be written as 2 times 5 raised to the power 5. Now 3 raised to the power 5 we cannot expand, so writing it same ways. 6 raised to the power 5 in denominator. Yes, this we can open as 2 times 3. Together raised to the power 5. 5 raised to the power 7. This we cannot open, it will come like this only. This first step clear, everybody? Okay, going to the next step. 5 raised to the power 2 multiplied. Now 2 multiplied by 5 raised to the power 5, that means this power 5 is applicable on both. Open it. 2 raised to the power 5 multiplied 5 raised to the power 5. And 3 raised to the power 5 is already there. Upon denominator. 2 multiplied by 3 having common power 5, so that means this power 5 is applicable to both. 2 multiplied by 5 multiply 3 multiplied by 5. And 5 multiplied 5 raised to the power 7 as it is. Now let us check out the cuttings. 3 raised to the power 5, 3 raised to the power 5. Numerator, denominator both cut. 2 raised to the power 5 in numerator, 2 raised to the power 5 in denominator also cut. Now what is left now? We are left with 5 raised to the power 2, 5 raised to the power 5. Let us write it separately. 5 raised to the power 2 multiply 5 raised to the power 5. And in denominator what are we having? 5 raised to the power 7. Same base in multiplication, different in multiply. What do? We add the power. So let us add them. 5 raised to the power 2 plus 5 upon 5 raised to the power 7. After adding, what will you get? 5 raised to the power 7 upon 5 raised to the power 7. Division. In division, what do? We subtract. You can do cuttings also. And if you have to, yes, actually we have to use the laws of exponents. So let us subtract. In division, we subtract the power. So 7 minus 7 gives us 5 raised to the power 0. 5 raised to the power 0 equals to 1. A rational number with power 0 is equals to 1. Avipsa, correct? See this question again step by step and solve it. Yes, Huma, correct. Manya, correct. I am rubbing the A and B part now. D part. The question is asking us 4 square, 4 raised to the power 2 minus 3 raised to the power 2 in one bracket. 4 raised to the power 2 minus 3 raised to the power 2 in one bracket. Multiply by 2 upon 7 raised to the power 2. This is the question. Now can we make anything same here? No. So another method. See, as per the question you have to think how it can be solved. So 4 square. So yes, 4 square is 4 4s are 16 minus 3 square, 3 3s are 9. 16 minus 9 in first bracket. Second, 2 upon 7 whole square as it is. 16 minus 9 is 7. Multiply by this division 2 upon 7 entire bracket with 2 power can be written as 2 raised to the power 2 upon 7 raised to the power 2. Here no denominator, put 1. 7 upon 1. Now 7 multiplied 2 raised to the power 2 is in numerator and 7 raised to the power 2 means 7 is written 2 times. Now cuttings. 7 ones are 7, 7 ones are 7. So now solve it. 2 twos are 4 upon 7 is the answer. So as per the rational numbers given in the question, to simplify you have to think which method will work, how you should start so that you can simplify it. And this will come when you will practice different type of questions. Okay. E part. 1 upon 3 raised to the power 3 minus 1 upon 9 raised to the power 3. It is in the bracket, square bracket. Multiply by 3 raised to the power 2. This is the question. I am rubbing the lower part. Everybody try this meantime. So how we can start it? 1 upon 9 can be turned as, can you repeat, ma'am? Kshitij, what to repeat? Which question you are asking me? The question is 1 upon 3 raised to the power 3. 1 upon 9 raised to the power 3. It is in minus entire bracket. Multiply by 3 raised to the power 2. Okay, this question only. Fine. We are doing this question. Now, see, if you write 1 upon 9 as 1 upon 3 raised to the power 2, as 9 can be written as 3 raised to the power 2. Okay, this is first rough work. You everybody understands and we will do fair. 1 upon 9 can be written as 1 upon 3 raised to the power 2 and further it is having power 3. Now we will do it like this, then entire it will becomes 3 raised to the power 6 because same one rational number with two powers we multiply the power. It becomes 3 raised to the power 6. Here it is 3 raised to the power 3. Any case it is not going to help us. So what should we do? We should open it. It will be easier for you. 1 upon 3 raised to the power 3 means 3 3s are 9, 9 3s are 27. 1 upon 27. Minus 1 upon 9 raised to the power 3. 9 9s are 81. 81 multiplied by 9, 729. In square bracket, multiply by 3 3s are 9. We have multiplied and opened it. Now this is unlike fractions, unlike rational numbers. So let us make them like by taking the LCM. Smaller number and bigger number, if you observe them, 729 is the multiple of 27. You can check out, you can take the LCM. 3 nines are 27. Here 3 twos are 6, 1 left. 3 fours are 12, 3 threes are 9. Again 3. 3 threes are 9, 3 eights are 24 and 1. Again 3 ones are 3 and 27. Shape of L. LCM. 3 times 3 times 3 times 27. 27 is single. 1 and 27 no common table, so you can leave it here. So LCM becomes 729. So take LCM 729. 1 upon 27. How to make 7 upon 729? Multiply by 27 will give you denominator 729. And second fraction is already 729. Multiply by 9 outside the bracket. It becomes 27 upon 729 minus 1 upon 729. Multiply by 9 outside, continued. What it becomes? 27 minus 1. 26 upon 729. Multiply by 9 outside. Cuttings. 9 ones are 9. 9 eights are 72. 9 ones are 9. It becomes 26 upon 81 is the answer. Simplify. This way we have done this question. So you can observe that each question we have done it different way. Each question has been done with different way. So when you will practice that only you will come to know that which method is applicable to which question. How to simplify the question. Okay. Write down quickly, then I will rub. Then we will go to the next question. Question number 3. Huma, correct. Correct, Huma. So I am rubbing the board. I hope everybody has written. Check. Your next question is find the value of n. Question number 3. Find the value of n. A part. Actually some maintenance work is going on in the society, so some noise is there. The people are working. 25 raised to the power n equals to 125 raised to the power 10. We can equate two rational numbers with the same base. So both should have the same base. Here first is having 25 as the base and second is having 125 as the base. So we have to make them with the same base. Find the prime factors of 125. 5 2s are 10, 5 5s are 25, 5 5s are 25, 5 1s are 5. So it comes 5 3 times. 125 can be written as 5 raised to the power 3 with outside power 10. And here, Zoya, pay attention, little bit correction beta. 5 raised to the power 3 has come up in place of 125 and 10 was already there. Now both the base should be same. Here it is 25 left side, right side it is 5. So 25 also to be written in the terms of 5. So 25 can be 5 raised to the power 2. And outside power is n. Now both the bases are 5, 5. Let us solve it further. One base with two powers, we multiply it. 5 raised to the power 2n equals to 5 raised to the power 3 tens are 30. When bases are same, powers are also equal. So write down, if bases are equal, powers are also equal. When bases are equal, powers are also equal. That means, now we are leaving the base. It means 2n equals to 30. Powers are also equal. 2n equals to 30. So n is, 2 is in multiplication, will go to other side in divide. 30 divided by 2 equals to 15. So n equals to 15 is the answer. Yes, Avipsa correct. Kshitij correct. Try out the B part I am writing here. The B part is 27 raised to the power n multiplied by 3 raised to the power n equals to 729. Yes, Huma, correct. Try this question. One base is 27, second base is 3, third number is 729. All we have to make with the same base. So yes, 27 can be written in the term of 3. 3 is already 3 and 729 can also be written in the terms of 3. So let us write 27 can be 3 raised to the power 3. 3 3s are 9, 9 3s are 27. And already power of n is given. Second, 3 raised to the power n equals to 729. Let us find the prime factors of 729. 3 2s are 6, 1 left, 3 4s are 12, 3 3s are 9, again 3, 3 8s are 24, 3 1s are 3, again 3, it gives us 27, again 3, 9 3s are 27, 3 3s are 9, 3 1s are 3. One raised to the power 9. Avipsa, where? See here, 3 is written how many times? 1, 2, 3, 4, 5, 6. So 3 raised to the power 6 is the exponential form of 729. Both the side you have to make the same base. Now, one base with two powers, power of a power, we multiply, it becomes 3 multiplied by n, 3n. Multiply 3 raised to the power n, already here, equals to 3 raised to the power 6. Now observe, first law will be applicable here. In multiplication, same base, different power. In multiplication, what do? We add the power. So it becomes 3 raised to the power 3n plus n equals to 3 raised to the power 6. 3 times n and 1 more n. So total n कितने हो गए? 4n. So 3 raised to the power 4n equals to 3 raised to the power 6. Both the bases are same. So powers are also equal. This implies, I am writing here, 4n is equals to 6. Bases are same, so powers are also equal. 4n equals to 6. Quickly tell me what n will come in the lowest term. This much I have done, now remaining you do. Find out the value of n. 4n equals to 6. So what n will come? Zoya telling one answer. Let us see what others are saying. Manya. Two different answers. Yes, Manya. Now both are same. So 4 is in multiplication here. We'll go to other side in denominator. It becomes 6 upon 4. Yes, Avipsa, same. Kshitij also. 2, cutting with the table of 2. 2 3s are 6, 2 2s are 4. So n equals to 3 upon 2 is the answer. Value of n. Yes, Huma, correct. 3 upon 2. I hope now it is clear to you. Concept is clear how you can find the value of n. The base should be same. If the base is not same, you have to make it same. Then only you can compare. Bases are equal, then powers are also equal. Important line. If bases are equal, powers are also equal. So same base, then powers you can equate and find the value of n. Clear with this? Now going to the next question. Question number 4. The question is, this is also find n such that, question number 4, find n such that A part 7 raised to the power 2n minus 1 equals to 343. 7 raised to the power 2n minus 1 equals to 343. This is the question. So both should have the same base. This much is clear to you, but till now. Now 343 you have to turn in the terms of 7. Find out the prime factors. Table of 7. 7 4s are 28. 6 left. 7 9s are 63. 7 7s are 49. 7 1s are 7. So how many times 7 has come? 3 times. So that means 7 raised to the power 2n minus 1 is equals to 7 raised to the power 3. Correct, Zoya? Now bases are same, so we can equate the power. Now don't do direct. Every time if such question come, you have to write this line. If bases are equal, powers are equal. Because reason you have to mention. You cannot just disappear the 7 and equating the powers. Mention the reason. After that you can leave 7 and go to the powers only. 2n minus 1 equals to 3. 2n equals to 3. Minus 1 go to other side, become plus 1. So becomes 4. 2 in division gives us 2. N equals to 2 is the answer. Clear? Yes, Avipsa, correct. Rubbing the board this side. Yes, Manya, correct. Uma, correct. Now try the B part. B part is 3 upon 5 raised to the power 3 multiply by 9 upon 25 raised to the power 2 equals to 3 upon 5 raised to the power 2 n minus 1. This is the question. You have to find the value of n. How we can find? By equating the bases. Okay? Base should be equal. 3 upon 5, 3 upon 5. 2 are having equal base. So 9 upon 25, yes, it can be written as in the form of 3 upon 5. 3 upon 5 raised to the power 3 multiply by 9 upon 5 means 3 square and 25 means 5 square. Outside power is 2 equals to 3 upon 5 raised to the power 2 n minus 1. Inside power 2, outside power also 2. One rational number having two powers. So what do? We multiply. 3 upon 5 raised to the power 3 and second rational number becomes 3 upon 5 raised to the power 4. 2 to the 4 outside equals to 3 upon 5 raised to the power 2 n minus 1. Now apply the first law. In multiplication, when bases are same, what do? We add the powers. It becomes 3 upon 5 raised to the power 3 plus 4. And this side it is same, 3 upon 5 raised to the power 2n minus 1. Zoya has written the answer. Let us see. Zoya, you keep on checking your sum. It becomes 3 upon 5. 3 plus 4, 7 equals to 3 upon 5 raised to the power 2n minus 1. Bases are same, so powers are also equal. You have to write the rule here every time. If the bases are equal, powers are also equal. After writing this rule, then you can equate. Yes, this side 7 and other side 2n minus 1. Minus 1 goes to other side, become plus, so it becomes 7 plus 1 equals to 2n. So 2n equals to 8. N equals to, Kshitij has given the answer. N equals to 8 upon 2 gives us 4. So yes, n is equals to 4. Everybody check your sum. Where have you missed it? N equals to 4. Yes, Manya correct. Kshitij correct. Uma correct. So I hope the concept is clear of such type of questions. Now one question I am writing on the board that you all have to try. C part. The question is 2 upon 3 raised to the power n multiply by 2 upon 3 raised to the power 4 equals to 64 upon 729. See, first rational number 2 upon 3, second rational number also 2 upon 3. That means 64 upon 729 you have to turn into the form of 2 upon 3. Find out the prime factors of 64 and the prime factors of 729. Waiting. You all find out and tell me what will come. Meantime, I am writing this side. Both the rational numbers are same base, so power will be added n plus 4. This side you have to tell me, right side. Prime factors of 64, prime factors of 729. Okay, I hope you people have done. So 64 can be 2 multiplied by 32, then further 2 multiplied by 16, 2 8s are 16, 2 2s are 4, and 2 1s are 2. How many times 2 has come? 1, 2, 3, 4, 5, 6. 6 times. So 64 becomes 2 raised to the power 6. Now come to 729. By table of 3. Same base we need, so same table. 3 2s are 6, 1 left, 3 4s are 12, 3 3s are 9. Again 3, 3 8s are 24, 3 1s are 3. Again 3, 3 2s are 6, 2 left, 3 7s are 21. Again 3, 3 9s are 27, 3 3s are 9, 3 1s are 3. How many times 3 has come? 1, 2, 3, 4, 5, 6. 3 raised to the power 6. Yes, correct, Huma. 64 is equal to 2 power 6. So how we can write it? 2 upon 3 raised to the power n plus 4 equals to 2 upon 3 raised to the power. In division, power is written in the numerator and denominator separately. So yes, we can write it together. 2 upon 3 raised to the power 6. This is your sixth law. Yes, Huma, correct. 729. Yes, Manya, correct. Okay. So now bases are equal. We can equate the powers. So n plus 4 equals to 6. N plus 4 equals to 6. We can equate the powers now. Find the value of n. N equals to 6 minus 4 gives us n equals to 2. Enjoy. Got the answer. Yes, Manya. Correct. 3 raised to the power 6. N equals to 2. Zoya, correct. Let us go to the next question. I am rubbing B part. Meantime, if you are writing the C. Question number 5. Avipsa, are you trying? Question number 5. If A upon B whole square. Yes, Huma, correct. Manya, correct. Zoya also correct. Write down the question along with me. If A upon B square is equals to 16 upon 9 divided by 4 upon 3 raised to the power 0. 4 upon 3 raised to the power 0. This is the question. And we have to find, this is given to us. And we have to find, comma. Find क्या करना है आपको? Find the value of B upon A raised to the power 3. This is the question. Using the first given information, we have to find the second information. So we have to find the value of A, we have to find the value of B, and both the values we will be putting up in the B upon A. So let us start finding. Answer: A upon B whole square equals to 16 upon 9 divided by 4 upon 3 raised to the power 0. I have just copied the question again. Now 16 upon 9 can be written in the form of 4 upon 3. We have to make the base same. Yes, 16 can be 4 square, 9 can be 3 square. 4 4s are 16, 3 3s are 9. So it can be written as 4 upon 3 raised to the power 2. This is clear? 16 can be written as 4 square, 9 can be written as 3 square. Divided by a rational number raised to the power 0 is equals to, tell me, a rational number raised to the power 0 is equals to, a rational number raised to the power 0 equals to 1. Yes, Avipsa, Huma, Manya, all are correct. Now, 4 upon 3 whole square divided by 1. Any number divided by 1 is the number itself. So that means it is equals to 4 upon 3 raised to the power 2 divided by 1. And this side it is going A upon B whole square. Here also A upon B whole square. Now reverse case will be used. When bases are equal, powers are also equal. That means when powers are equal, bases are also equal. So from here we are going to find the value of A and B. Both the powers 2, 2. So that means A upon B equals to 4 upon 3. A equals to 4, B equals to 3. Reason? Yes, we have to mention the reason. If bases are equal, every time we have to mention bases are equal, then powers are also equal. The reverse of this we have applied, that powers are equal, so bases are equal. The reverse of this we have applied. So A equals to 4, B equals to 3 we got. Now question क्या पूछ रहा है आपको? B upon A raised to the power 3. We have to find the value of A. So write down value of B upon A raised to the power 3 equals to, in place of B we will be writing 3. In place of A we will be writing 4. 3 upon 4 raised to the power 3. Solve it further. 3 3s are 9, 9 3s are 27. And denominator 4 4s are 16, 16 4s are 64. 27 upon 64 is the answer. Is it clear, children? Yes, Kshitij, correct. Rubbing the A part. Now the last. Okay, Habibsa, correct. Yes, she is telling clear. Now last question of today's class. Let us do one more. Yes, ma'am, it is clear. Okay. Kshitij, question is find the value of. Okay. So, if you write the answer 3 upon 4 raised to the power 3, so it is not complete. Find the value of means उसको भी further solve करके final लिखो 27 upon 64. If question asks write in exponential form, then this is the answer in exponential form. If question asks find the value of, final answer is 27 upon 64 is the final answer. Value. Question number 6. Note down. Find the value of n so that what is given? So that minus 3 raised to the power n plus 1 multiply by 9 square equals to minus 3 raised to the power 9. This is given to us. Okay, Kshitij is clear with the concept now. First base is minus 3 and equals to side is also base minus 3. That means all base we have to make same. 9 can be written in the form of minus 3. Yes, 9 can be written in the form of minus 3. Let us write. First one minus 3 raised to the power n plus 1 multiplied by 9 can be written as minus 3 square. Minus 3 square means 3 3s are 9 and minus minus plus. It will give you 9 only. And further it is having 1 power 2. Minus 9 raised to the power 2 is written in place of 9. And already 1 power 2 was given, that is also written outside. And other side of equals to, it is minus 3 raised to the power n. Now solve it further. Minus 3 raised to the power n plus 1 multiply by 1 base with power of a power, 2 powers, power of a power, 1 base with power of a power. What do? We multiply. Minus 3 raised to the power 2 2s are 4 equals to minus 3 raised to the power 9. Now all have turned into minus 3 base. Minus 3, minus 3, minus 3. Write this. Minus 3 raised to the power n plus 1 minus 3 raised to the power 4. In this now first law will be applicable. In multiplication with the same base, powers are added. First law. So it becomes minus 3 raised to the power n plus 1 plus 4. Both the powers we have added. Plus 4 equals to minus 3 raised to the power 9. Let us solve it further. Minus 3 raised to the power n plus 5. 4 plus 1 is 5 equals to minus 3 raised to the power 9. Now that rule will be applicable. If powers are equal, bases are also equal. Both. And if bases are equal, powers are equal. Here bases are equal. Minus 3, minus 3. So powers are also equal. That means n plus 5 is equals to 9. Same rule applicable every time. This same. When we have to find the value of n. So n equals to 5 goes to other side. 9 minus 5. N equals to 4 is the answer. So I hope the concept is clear. How to find the value of n, what are the 6 laws of exponent, how to use them. Yes, Kshitij correct, Manya correct, Avipsa correct. Uma correct, okay. Now again, let us revise quickly a quick recap. There are 6 laws of exponent. How many laws? 6 laws of exponent. First one, when the bases are same. Okay, I'll write. I will make some space. A quick recap. If bases are same, a raised to the power n multiply a raised to the power n. In multiplication, bases are same, so we add them. A raised to the power m plus n. This is multiplication rule. Now division. a raised to the power m divided by a raised to the power n. In division, what do? We subtract m minus n. Okay, yes, m should be greater than n. इतना ध्यान रखना है because m minus n, from bigger you have to subtract smaller. Third rule, power of 0. A rational number with power of 0 is equal to 1. Fourth rule, a rational number with two powers, a raised to the power m and then again raised to the power n also. Power of power. In that case, what do? We multiply the powers. M multiplied by n. Fifth, product. Power of a product. You are having two rational numbers a and b. Both are in multiplication having common power n. That means this power is applicable to both a raised to the power n multiply b raised to the power n. Sixth one, I am writing here. Okay, here. Same ways as in multiplication, power is been applicable to. Third is it? Okay. You just remember the 6 laws. The sequence is not that important. A upon b raised to the power n. So that means the power is applicable to both a raised to the power n, b raised to the power n. Here what is to be taken care? B cannot be 0. Denominator cannot be 0 because in that case it becomes not defined. Okay students, this much for today. Clear? So I will be winding up the class. Thank you. Keep practicing. Practice all the laws and the questions also. Bye-bye.